Alright, big brother, we're going to take it for a ride.
Welcome to iLectureOnline, and today we're going to do some problems involving Coulomb's law. So we're back in the realm of physics.
Go on.
And just as a reminder, here's the equation that describes the
If I've
force
done things correctly.
that exists between any
If
two
I've done this
charges
right.
called Q1 and Q2.
But we're going to get into the F and the equals being
K is a
part
constant
of this
proportionality,
monster while you're
and
looking
K
at it. Just the
equals
physical action
9
of
times
F.
10 to the 9th
Watch this.
newtons meters squared per, not kilograms. I was going to write kilograms. Well, that's for newtons.
So good.
Law of gravity. But,
It'll make a conservation, one of information. There's a real
charge.
bit about it why this K
So here's
is
our problem.
not
It
a
says,
standard K. It's got to be a
6
special K.
microcoulomb charge, and
You know why
microcoulomb
every
is 10
letter
to
in
minus
here
6
is
coulombs.
capital
Placed at
case.
the origin, and a minus 4 microcoulomb charge is placed 2 meters to the right.
Yeah, I wrote that different.
What is the
And you
force
could
on the
play
first
with things in
charge
there.
due to
A
the presence of the
and
second charge, and what is the force on the second charge due to the presence of the first charge. So, as
See,
we usually
so
do,
what's real cool
we
about
wanna
this
draw
is
a
two
diagram
things.
So we can get a visual picture of
It's two
how to do this
things.
problem.
It's that thing when I get the number
draw
of
a
it, and
coordinate
that
system.
number when I get the thing
There's the y-axis,
will be a
there's the
time
x-axis.
or something weird like that.
Place one charge.
And so
it
they
looks
jump
it's a
around like
positive
that.
charge, so we
They do
place a
that.
positive charge,
Positive.
call it
Motivated.
Q1, that's equal to 6.0.
So Dungeons and Dragons
microcoulombs.
and Warhammer, if
says
you
we
like
have a second
Warhammer,
charge
we'll
to the
work a
right.
board like that.
Place
See,
a
I can
second
show you up
charge
on the
here,
presentation.
that's a negative
We all know the
We'll call
standard
that
rules.
Q2,
We can't
that's
get off
equal
that
to
board
minus
right. It's like
4
as long as the schematics are
microcoulombs.
inside there,
Well, I
salties
should
will
say
jump
minus 4.0.
barbed wire and eat
Be a little bit
grenades.
more accurate.
And everybody's fine with that
There we go.
apparently. And those are those charges. When you
And we
get
need
into
to
the other
find the
ones later.
forces
But there will be
on each other
like a
due to
version
the
of it
charge.
where I
So how
just
do we
like to
do
put the
that?
teacher
Where do we
and
start?
me and you salty, except
Well, the
for
first thing you
instead of
wanna
us
do is
having
draw the
positive
vector
charge or
diagram. So
doing
the
whatever
vectors
other
represent
version
the
of this might
forces.
be happening.
And so let's go to our first charge
You
right
gotta
here. And what would be
kind
the
of
force on
idealize
this
what's the
charge
photon
due to
for
the
this,
presence of this
because
one?
you'll take
Now, they're
kind of my
opposite
stuff
charge,
with the
and we know
photon
that opposite charges
into this,
attract.
which
That
skitters
means
out
that
a
this force is being, or this
a
charge is being
positron,
pulled this charge,
a negative and a negative,
so
or
we
a
can
negative
draw
and a
the
positive,
vector this way.
a
So call
negative
this
or a
F
negative electron.
on
Somebody could say
1.
something at
So
that
let's call it
classroom,
F on
right?
1.
Kick it in there. And you could get a positive
of
result out of this
2,
because
charge 2.
charges
Now
work like this
also,
apparently.
since we also have to find what the force is on the second charge.
But usually,
we go
because
to
we're
this
all
charge here and
right-hand
say, well,
rule in a
how
current,
does this
it would
charge
be
influence
odd.
that charge? And
It
again,
would
since they're being
heat
attracted,
or
we
magnet.
could say that it's being pulled towards this charge, so we can draw a force vector
And
this
so
way,
each of
which is
them, but
F
remember,
on 2.
he
And of course,
does.
since they're
We could
vectors,
get this
we
thing on
indicate
YouTube,
that they're
but
vectors.
is it in a form
Alright.
that's one
So now that
congruent for
we have
you and
at
the
least
way
got a
you
visual
train?
picture of what's going
And
on.
again, I
Now we
recommend
have to
nut
find the
and bolt
magnitude
in
of
this.
this
Just don't
force,
blow
F1.
through it. When they
And
do
so
a
to find
line,
magnitude,
you do a
we
line.
can use Coulomb's law.
You get Coulomb's law,
Get
Coulomb's
rid
law.
of
So
a little bit
you
of
got to
this
get
line
used to
here,
that
give
little
me some
bit.
more
What I
room.
mean is he's going to move at the speed of
There
light
we go.
here, and while you're at 10,
So using
6,
Coulomb's law, we can say that
minus.
the force on 1 is equal to
Now
K
you remember,
times
okay,
Q1,
K, Q1, Q2, and it
divided by
comes
the
up in
distance of the
positions
unit
like
squared.
this all the time. He'll write it out.
Alright.
I might change this. I might move where I would
Now,
see that
we
because
plug
it's
in the
already
numbers.
up there.
So this is equal
But
to K,
F1,
which is 9 times
he's
10
saying
to the
idealize
9th
the position. Now,
newtons
apparently, this one is
meters
not
squared
like
per
those other
coulomb
ones
squared.
in the way he was doing it, and I would
Times the
maintain
magnitude of the first
what
charge,
that system
which
is. It's a bit of a squishy.
6.0 times 10 to the minus 6
We don't have
coulombs.
much room to play around in here.
Magnitude of the second charge. Now here you say, well, there's a negative there. Should I put a negative in? Well, the best thing to
So,
think about it is, let's just say that
catch you on the next one.
we